On that note, we'll start off today's seminar. I'd like to introduce Dr. Brian Miles, who's trained as a software engineer and physical geographer. His PhD research focused on ecohydrology modeling in urbanized and forested watersheds. This work included tools to support reproducible ingest and transformation geospatial data, as well as model calibration and uncertainty estimation using HPC resources. He has a current and prior experience in software engineering, Internet of Things or IoT, environmental monitoring, geospatial data storage and analysis, and managing safe, agile teams. His professional interests include developing workflows and reproducible analyses. Dr. Miles is currently focusing on translating research codes and algorithms into software artifacts supported by robust documentation, automated testing, continuous integration, and deployment observability, fault tolerance, and scalability. So let's give a warm welcome to Dr. Brian.
Thank you. I think I need to update and shorten my bio. So today I'm going to talk about the WIBL project in part. WIBL, I'll get into what that means, but really what it's about is I'm focusing on open tools for community bathymetry data collection, management, and contribution. So first I'll start with the definition of what is community or crowdsourced. You might have heard bathymetry, volunteer bathymetry. This is an official definition. Kind of been put together very carefully because by the International Hydrographic Organization, because some nations aren't so keen on people collecting data in their water. So the idea is the collection of depth measurements from vessels using standard navigation instruments while engaged in routine operations. So it could be a fishing vessel, other commercial vessel, or even pleasure vessels like this luxury yacht. And so what's the role of these data? How do people envision them being used? And the two sort of, I'll note first, there's two sort of acronyms you'll see, CSB and also VBI, Volunteer Bathymetric Information. So I'll kind of use those interchangeably. The roles for these data as envisioned by the IHO are to support national and regional development activities. So you might think of supporting the blue economy, ocean-based economic activity. Also filling gaps where data is scarce. You can think in particular the Arctic, especially where you have very sparsely populated areas, but there's still a need for communities such as indigenous communities to map their resources because they're likely not getting mapped any other way, just given the amount of resources at the national level. Also, these kind of volunteer crowdsourced community data are useful in shallow areas where you can't get a normal research vessel or a survey vessel, although I think this is changing the uncrewed systems. It's also good to ideally to identify uncharted features. So you can think about if you have lots of volunteers collecting data over an area and they're all sort of seeing some anomaly that's different from what's charted, even if the absolute value is off, it could indicate something that's not been charted and should be. And relatedly to verify that charted features are what they say they are. And to confirm, if charts need to be updated for new places people are going and new uses, perhaps. Why do we care about all this? Well, you're probably familiar with this map, the Murky Waters map. It's a nice piece of cartography showing the world ocean and the unmapped areas. Relatedly, in the U.S., there's a report every year, I think, in the unmapped waters. Currently, as of January this year, about 48% are unmapped. In the U.S. and globally, currently only 26% of the world's oceans are mapped with publicly available data to modern standards. So, how do we map these gaps? And this is one major effort behind that is the Seabed 2030 project. And on the your right here, there's a shot of the paper from 2018 by Dr. Mayer et al. Laying out the Seabed 2030 project, and this is a collaborative effort between many across the globe. It's managed in large part by GEBCO, the General Bathymetric Chart of the Ocean, and it's sponsored by the Nippon Foundation to facilitate the complete mapping of the world oceans to modern standards by 2030. I'm probably won't get there maybe, but it's good to set a goal and we get farther than we would otherwise, and eventually we will get there.
Called an aspirational goal.
Aspirational goal, yeah, there's value in setting aspirational goals, no shame in
It
that.
used to be called an aspiration.
Oh, no, it was. Amongst ourselves, the proposal didn't necessarily say that.
So how do we get from this 26% currently to 100%? Well, Seabed 2030 has a few ideas on that. One is, and methods, collating existing public data. There's lots of data sets out there. Let's bring them together. And a lot of the really hard and important work that GEBCO does is kind of combine them into one seamless grid. It's actually quite a bit harder, I think, than it sounds. Identify existing non-public data sets and convince people to make them public. But I want to focus on one with respect to community bathymetry is to identify areas where no data exists and to inform future expeditions. And to this end here, recently in the last week or so, Seabed 2030 released a report of use cases for the Seabed 2030 data that we're all collecting. And one of the use cases is around exclusive economic zone mapping in the absence of a national hydrography office. So you can think of nations with less resources or very small island nations, they may not have a professional hydrographic organization. And for these groups, these nations, they can use the GEBCO Seabed 2030 data, but also rely on other data sources such as crowdsourcing to fill needs that they have. Okay, so how do we put this into practice? One way is through the IHO. For about 8 years, there's been a working group, the CSB working group, and it's their job to coordinate these efforts, across IHO member nations and others. And one of the ways that they have been doing this is by developing the B-12 recommendations or guidance on crowdsourced bathymetry. You can think of it sort of as a best practices document in a way. But part of that is describing the metadata and data requirements and optional elements that crowdsourced or community bathymetry data should have. This is more conceptual though. And I'll talk about it in more detail in terms of how to operationalize it is sort of left outside of the B-12 guidance. It's not a standard, it's not like S100 or anything like that. It's a little different. So according to the IHO model, this is how community bathymetry should be collected. Kind of start from the left to start from the right and go to the left. So the idea is ultimately the data would end up in the IHO the Data Center for Digital Bathymetry, DCDB. You might see that on future slides, which is run currently by NOAA out of one of their data centers in Boulder. But you don't want hundreds or thousands or potentially hopefully millions of vessels contributing data directly to that data center archive, DCDB archive. So the IHO envisions trusted nodes in the middle there as an intermediary. And their job is to collect data from vessels, manage the data collection process, package the data up, ensure some amount of data quality, and forward that on to the DCDB. But there are still challenges, even for groups like trusted nodes. There's still data management challenges in this workflow here, and I'll just talk quickly about that. So the idea is, in the most abstract sense, you've got to collect the data out of from the echo sounder or other navigational equipment, attach vessel metadata, convert into the IHO, the B-12 format, validate those converted data, and ultimately, hopefully, submit to the DCDB. But this, even for trusted nodes, can be challenging, and above all, what we're trying to do is make this process of submitting and contributing data as easy as possible for everyone. The challenges can be lack of time and data management expertise, and lack of tools. So what we really need is a minimum cost, minimum functionality, or minimal functionality rather, data collection system. That's important, system. It's got to be integrated for community bathymetry. And this is where I want to start talking about the WIBL project. WIBL stands for the Wireless Inexpensive Bathymetry Logger. Curious about where that acronym came from, talk to Dr. Calder. I think it involves Rowan Atkinson. So WIBL is a minimum cost, minimal functionality, and also importantly, open source hardware, software, data collection system for community bathymetry. And what we have here is an example of one of the data logger hardware boxes that we've produced. It's got its own 3D printed enclosure, the box is in there. And in the ideal case, it's as simple as plugging in the CAN bus connector there, and it wakes up and should start collecting data. So the hardware, here's more of the hardware to show that we've created more than just one. There's the board there that Brian designed and built and tested. I believe this was a COVID project. Yeah, so it's great. And importantly, it's open source hardware. All the plans and everything are online, and the CID company has taken this design and built their own version of the hardware. It's still software compatible, but they've tailored it to their prospective users. So it demonstrates that openness all the way down to the hardware level, which is great. So the hardware, I'm not a hardware person, I don't know all these symbols, but I can sort of interpret some of it for you. So at the core is a data logger, or sorry, is a system on a chip, a microcontroller, ESP32. If you know anything about microcontrollers, that's a popular one. And it's fed data from either NEMA 2000 over the CAN bus connector I showed you, or the older NEMA 183 over standard serial lines. The data goes in, has some minimal processing applied, and gets stored in the by the SD card. Now in terms of the software, this is an earlier version of it where we would get the data off the SD card via an app on a phone, and then the phone could upload it into the cloud for processing, and then eventually submission into DCDB. These days this little black part here is actually an antenna for Wi-Fi and Bluetooth and maybe other things. The data logger can be optionally configured if you want. If you have an internet connection, which now with Starlink we do more and more at sea, it can occasionally upload data by itself, so even simpler. And then just to kind of step back and talk about the entire system, we can get that data off of a native WIBL logger, or we can convert from other logger formats into a data store and then processed and eventually into the cloud system. So you can see this is not just specific to the WIBL data loggers, it's a more generalizable system. So now I want to talk a little bit more about some of the WIBL data processing tools. We have this workflow here, again I want to remind you of getting the data from the echosounder and other sensors, attaching the metadata, converting it, validating it, and submitting it. And given the standardized nature of the IHO B-12 data model, we think it's reasonable to start adopting standardized data management tools across the CSB community. And we think the WIBL tools provide a way to do that, right? And so the goal here of the WIBL data management tools is to provide a trusted node in the box experience to help accelerate the startup of trusted nodes, provide tools that can be used locally or in cloud environments, depending on your needs, provide scripting to enable batch processing, processing data from different kinds of loggers, as I said, and doing serverless cloud data processing for efficiency. And I'll talk more about that. So, now I'll start with that. So here's the suite of tools we have. The log convert tool does that conversion. It currently supports team serve and yacht devices loggers in the WIBL format. Once you have it in the WIBL format, we have a suite of Python tools that allow various processing steps. And these tools are great, but they're labor intensive. They're good for debugging and working with individual files, bringing on a new vessel on board into your program and making sure the data looks right. But it quickly became apparent that we needed a way to automate this, so we worked with Chris Schwartz in our IT group, he wrote our initial PowerShell script to automate the conversion of data for one of the trusted nodes, and it turned out great. It worked great, and we realized, oh, this isn't just a Windows tool. It works great in Linux and Mac. So built out scripts for all parts of the data processing workflow, and then we have analogs for cloud processing as well right now in AWS. That's another option as well. We can also, here's all the places we can deploy this: Linux, Mac OS, Windows. Also, Docker container. If you're not familiarized with containers, it's just like shipping containers, but it's for software. It's just a more efficient way to distribute and use software. And then obviously in the cloud, we can deploy with, right now we're using AWS's Lambda. If you're not familiar with that, that's just their serverless product. You essentially upload your functions to run, and you don't have to worry about how it's run. It just runs it for you. But I want to go into a little more depth on this process here. An important process in the workflow is going from the WIBL data file, which are binary data files, so it's computer accessible, not human readable, to the JSON format, which is the B-12 format that humans can read and what we actually submit to the archive. So I want to talk a bit about that. So as I said, the B-12 guidance document doesn't say how to actually write the data down or encode the data from community bathymetry, but there is typically a JSON encoding for it. JSON is the JavaScript object notation. If you've ever gotten data from a web service or something, it might have been in JSON format. It's very human readable. It's easy-ish for a computer to read too. It's relatively efficient, so it's a nice kind of medium point. And so the JSON encoding can encode everything we need, but it doesn't provide any kind of robust validation. It can just say, hey, this is a number, this is a string, this is a list, this is a composition of multiple fields, an object. So we can't really, we're limited just by using the JSON. So to move things forward and to provide more reliable data, we built out a JSON schema for the data type. And JSON schema is just a clear language that allows you to sort of say what are if you're building a document of a certain type, what should be in it, essentially. And this is just an example. So a schema file is actually written in JSON. Kind of, you see this curly braces and the square brackets and the quoted strings and the colons and things like that. So the schema is on the left that describes the content that should be in the document instance on the right. You don't have to read all that. I just wanted to show you, indeed, it is human readable. So what can this do for us? So it does out of the box for free. Once we have the schema, we can do simple structural validation. What's required? What are required properties? What are the min and max number of items if we have a list of things? We can do enumerated values like our identifier types for vessels. IMO IDs is one kind of way of identifying a vessel. MMSI is another, for example. You can do regular expressions, which is that is actually not human readable to most humans, but it's a way of describing how text ought to be formatted and how you can validate it. So for example, you can write a regular expression that describes how a date should be written. And it makes it very easy and quick to check whether the dates are right, in the right format. What the JSON schema can't do is it can't do complex semantic validation. So that the ID types, for example. You have to look at nodes in different parts of the tree to do that validation. You have to say, okay, what's the type of ID? Oh, it's an MMS, it's an IMO ID. So therefore, the actual value of the ID has to start with IMO. It shouldn't start with anything else. That kind of validation the schema can't do by itself. So for that, what we did was we built a software package called CSB Schema. It's a Python package. You can install it easily from PyPy that allows you to validate these data. It also provides examples, tests, things like that, and it provides a command line tool so you can integrate this with any automated data workflow like what WIBL does. And we've released this independently of WIBL because it's generally useful to the CSB community. So now I want to talk back into to WIBL. How are people using these data management tools today. So use cases. And I'll share a few here. There are others that are possible. One example is Seakeepers, so a nonprofit based out of, I think near Miami, Florida. But they have a project where they're taking data from existing vessels. They have non-WIBL loggers, data loggers. So they convert the data using log convert. They use the Python tools to do some debugging, and then once they have a vessel onboarded, then they can use the PowerShell scripts to automate the conversion of the data, the validation of the data, and the submission of the data into the DCDB. Similarly, our colleagues at Comet, at USF, they're using WIBL loggers. So they don't have to do the conversion, so they have the data, but then they feed it into the same Python tools, PowerShell scripts, and submit to DCDB. One of a commercial collaborator, Orange Forest Marine, does something a little similar to Seakeepers. They're taking, they've started off with non-WIBL loggers. They're starting to get more into WIBL loggers, but they're converting the data and then doing AWS cloud pipelines to process the data and do their own custom processing and then submit to DCDB. But this is part of where the impetus for developing a Docker container came from, because it can be kind of a bear to install these pieces of software into the cloud and make it usable. And so this makes that a lot easier. Other workflows are possible. You can have hybrids, pulling in data from different types of data loggers, using the Python tools first, and then maybe as your maturity level increases, use the PowerShell scripts to do some automation, and then ultimately maybe if you want to, running it in the cloud. And it's important to note that the data don't have to go into the DCDB, though we'd love that. They can go on premises, they can go to cloud storage, so the users have full control and ownership of their data at all times. The most scalable though way to do this, and scalable in terms of getting the most data from the most vessels as quickly and with as least work as possible, is to use the native loggers, the WIBL loggers, which has the ability to configure each logger with the metadata for that vessel, and then that can allow basically completely automated processing through the cloud to on-premises or cloud storage, or to the DCDB. It's important to know we do want humans in the loop though, so there are ways to monitor these data flows as well. We're working on more ways for that. So other users are Canadian Hydrographic Service, CIDCO, also in Canada, Seabed 2030, and CID. So what are some of our next steps? First, we want to start harmonizing the WIBL tools with this new initiative that Brian's working on and others are working on, coming out of the working group called OpenVBI. So this provides reference algorithms for volunteer bathymetry information processing. And I'll talk a little bit more about that in a minute. Also keen to develop additional cloud vendor adapters. The way this code is structured, it's pretty modular, so it's pretty easy, not much work to add support for, say, Azure or Google cloud platforms. Another thing we've thought about is potentially a graphical user interface for beginners. We're still not sure about this. I think would be valuable for some, but it's really hard to make a good graphical user interface that is extensible. Our tools right now take some learning, but once you learn them, you can do anything you want. This graphic here is an example of output from an automated visualization we've developed in the cloud. So you can take data from one or more files that have been processed through the pipeline and plot them on a map. It's a nice thing that Trusted Nodes, it's an example of what Trusted Nodes could do to have an easy artifact to give to contributors to say, hey, here's your data, please give us more data. Look at how great this is. So the OpenVBI tools, the idea here is to speed the adoption of volunteer or community bathymetry by sharing as much as possible the data processing. So we don't reinventing the wheel all the time. There's certain core things that we can do and just share with them. So one is adapters for data, so getting data into the system, kind of like our log convert that we have for WIBL. Another thing is these core things of just managing data sets, building doing interpolation, figuring out the depth reconstruction to actually make an XYZ time sounding point, doing uncertainty estimation. The things in blue are things we're more working on. doing corrections, so water level corrections, datum correction, things like that, super important for CSB to make it more useful. Doing filtering, throwing out preposterous depths or preposterous dates or data deduplication, outlier removal, things like that. So you might notice though, there's some overlap here between some of what WIBL does and what OpenVBI does, in particular in bathy data processing, and then also creating B-12 data and metadata. And so what we're working on going forward is to sort of factor some of those common pieces out of WIBL into OpenVBI and then pulling them back into WIBL as dependencies. And that way, sort of, we can eat our own dog food, but then also, just reduce the amount of duplicative effort and things we need to maintain. There's only so much effort, resources we have for these things. So with that, I'm happy to take questions or have any discussion. There's links to the repositories there if anybody's interested in playing with these tools. If you're interested in the hardware, talk to myself or Brian. And I thank you for the invitation.
Do you have any questions?
Yeah, you said it was accessible in Linux, so does that mean there's like a bash equivalent to the PowerShell tools, or
Nope, you just install PowerShell.
okay.
Yeah. You don't want to duplicate.
Yeah.
And that's what the container actually installs PowerShell.
Okay.
So if you don't know how to do that, which I didn't know how to do it until I added it to the container, that's a recipe, or you can use the container directly. Yeah, it's actually, I didn't want to like PowerShell, it's very verbose, but I understand why they did it that way, and it's actually pretty good.
But the tools are built the same way that other Unix tools are, so if you wanted to use them in Bash, you can do that as well, that's why you first.
So it will run in Bash?
The scripts won't, but the Python's.
The scripts would,
yeah.
But it's very easy, I mean,
You could
to do the equivalent of what scripts do in Bash, you can basically type by hand every time you want to use it, it's not.
Yeah, or you could, if you know Bash scripting, you can kind of blur your eyes a little bit, and figure out what the PowerShell's doing and read.
The intent of these PowerShell scripts, remember, the target audience for this application are people who have limited or no IT background. And so if we said to them, hey, you need to install Linux, hey, you need to learn how to use Bash scripting, and then you need, and then you do.
Okay, fair enough.
So the intent of the PowerShell scripts is to say, you need to know, understand what they're doing. Once you understand that, there's a thing an artifact you can use that will do the majority of this for you, and you don't have to keep thinking about it. You don't have that thing written. So that's the intent.
Oh, yeah.
Yes.
To add on to that, in PowerShell, it's really verbose, yes. Like if you want to do ls, it's get-child item, which is awful, but you can just do ls and it's alias to it. So if you look at the PowerShell scripts, you can basically just translate all of those PowerShell commands to literally ls, cd, mv, anything you want. It's pretty straightforward, I would imagine.
Well, my question is, how scalable is this when you start having a lot of volunteers dumping a lot of data, all this data getting processed in the cloud or even locally? How scalable is, how much computer power is this service?
Oh, I think that part's easy. The hard part, I think, is scaling it in terms of tracking it and keeping track of what's gone in, what's been processed, what succeeded, what failed. Managing your cloud storage so you don't have raw data sitting there forever if you don't need it anymore. And because of that, we're actually right now working on more cloud, the management piece, is because the cloud tools have a little manager they check in with whenever they do something, so we have a paper trail. Now we just need to build, you build a user interface to say, okay, here's all the files from your vessels. Here's the ones that have been converted.
Like a loading bar.
Sort of, but just being able to track it and then say, and then you
Like
could say, oh, this one succeeded, or these ones succeeded, let me either archive them, so maybe move them to cheaper tier of storage, or download them and then delete them. So that kind of, I think that's where the scalability is hard, because once you set up the cloud infrastructure, It's Lambdas, I mean, and it's in S3 storage, bucket storage. That's all built to scale already. It's just how much you wanna pay.
I would argue that the scalability problem is convincing people to do it.
Well, yeah, sure, yeah. Assuming they do it, then, yeah.
The other component of that is that because it's all open source, anybody who wants to collect their own data can just clone the entire thing and collect their own data. So each cloud instance that's doing the processing only has to process for that particular collection event. And then you have another copy that does for the next. So everybody pays a little bit, but nobody pays a lot. And so even like local yacht club or local hunter community in an indigenous community or whatever can collect their own data, own their own data, optionally contribute it, which we try to encourage, but you don't have to if you don't want to. It's a very sensitive subject in many parts of the world. But because we provide all the tools, they don't even have to understand the cloud. There's deployment, you hit the deployment, it will send it all into the cloud for you, set it all up, and we give you the information you do a piece. The goal for the entire project is to make it as seamless as possible, as frictionless as possible, for anybody who wants to collect their own data to be able to collect and own their own data, but still, because there's a standard system behind it, generate that data in the right formats that goes smoothly into the archive. The archive then doesn't have to negotiate with every contributor, because that would just kill the archive.
Yeah, and that's the key for the validation too.
You've got very scaling.
Make sure the data coming in are good. So we wanna validate. If it doesn't validate, at least the way the cloud stuff is set up, it won't do the automatic submission. Still doesn't mean the data are good, they're, it could be valid but also not good, but it cuts down on the amount of bad data. At least malformed data. Yeah, Kim?
Whenever I see something like this, the idea of crowdsourced data is so appealing because it's free data that we don't normally have. And it goes with the idea that, well, more data must be better than less data. However, more data is not necessarily valuable if it's redundant with what you're already collecting. And so I'm just curious, with the data to date, the data that you've collected to date, are you starting to see that it's actually filling in gaps? Or is it just going temporally and spatially, doing the same things that we're already getting the collection of?
Yeah, that's a good question. That's more of a DCDB area. They're the ones, I mean, they have products out there, they have a data explorer, you can download data, you can see what's been collected. Larry has a
It's a really good question, but if we take a look at an example that's existed for a number of years, something called OLEX, which is a crowdsourced mechanism but kind of private, and so the data is only allowed to go to the subscribers to it. It has been extraordinary in the near Arctic, Iceland, Scandinavia. It's filled huge gaps in bathymetric coverage.
With accuracies that are remarkably good.
With accuracies that are remarkable when we
really
compare it to, yeah, no, it really is quite amazing. And I think, I made the cynical comment that the real problem is getting the crowd, because no fisherman wants their vessel to be tracked. Governments are all suspicious, everybody's suspicious. But I think the OLEX model has demonstrated that if you can convince the community, which he has through the product, that the collective result of this effort is so much more valuable than their little snippet that they owned before, that they've well bought into it. So there is a really good example of how this is.
And that's exactly what I'm getting at, is areas that are like in the Arctic that are difficult to access. There's no jet skiers going up there, so you're not going to get data from them, so you're not filling that sort of thing in. But if you are seeing gaps that are being filled, albeit with a potential loss of accuracy that potentially has to be accepted, then it's useful. It's just if everyone's on the same shipping lane at the same time,
Yeah, but
it's not adding value.
That's good, it's a valid point, but that's not the crowd. In my view, that's not the crowd. And I'm not unchallenged in that view, that's normal. So the crowd in this instance, I think, is much more likely recreational vessels. The large commercial vessels, SOLAS class vessels, stick to the shipping lanes because they're the cheap, they're efficient, they know they're covered, they know they're not going to run aground because if they run aground, they know they're going to do it, which they occasionally do. So the bit that's going to get us the widest possible use are the millions rather than tens of thousands of recreational vessels out there if we can convince them, and that means yachters, day boats, pilot boats, tugs. You know, the ships that go everywhere rather than the ones that stay in their lanes, particularly.
Particularly the ones that pay
Convincing
no,
them is hard. It's
yeah,
not-
particularly the ones that pay no attention to the chart. And we'll go in all these areas that are dangerous in navigation, and we'll start collecting data that we really don't have.
But one interesting, just by way of a couple of examples, Olex is a really fine example. There are many others in the commercial world. All the recreational echo-sounder manufacturers do something similar. They're all closed gardens, they're private. You can only get them if you're part of the environment. With the data that's currently in DCDB, a number of hydrographic offices even have done updates to charts based on that data. Either they've taken the data entirely and put it right on the chart, or they've used it to work out where the chart needed updating and then went and updated the chart with other data from that area there. So this is not hypothetical, it's being done right now. There is value in that data. Maybe not necessarily the same value we get from a professional survey done in that area, but at least enough even if it just indicates where something has changed. The classical example that Adam Smith used to use is there was a chart in Atchafalaya Bay in the Gulf of Mexico where the AIS data for the ships that were there was going right over round because that area is very variable and the shoreline had changed dramatically since the chart was last there. So if you look at the chart, there's solid ground here and the ship's going right over it. Now, clearly that the locals know where it's safe to go, right? And so even if the data just provides that, then there's value in this data. But I think the data can potentially provide a great deal more than that, and that's certainly the examples that we're seeing, particularly from NOAA, particularly in Alaska.
Yes,
Have you begun trialing this with recreational boaters locally?
we have not, I don't think. No,
Locally, no.
locally, no. Others have done it. Coleman is doing it well, they were doing it. I don't know what they're doing now. They're probably cleaning up their basement.
Yeah,
No, they don't have basements.
Don't exist anymore, yeah.
Yeah, so hopefully all the folks at USF are okay. Yeah, but others aren't. But, you know,
You have to think about priorities for
Yeah.
our resources at the centre.
Mm-hmm.
And so what we're trying to do is to have a model where we provide the tools and we help people get used to them. And we have other people doing, deployments of them. And we've done that through Orange Coast Marine, through CIPCO, we work with Indigenous communities in Canada and with Common as well. And we're trying to encourage as much of that we can. There's a limit to how much any of these we can actually build and just give away because we're a research organisation. That's why the CID connection is really good because they're making commercial versions, which are sponsored primarily by Seabed 2030, which they can give away. So we're hoping it will scale out, but it's kind of getting that first scale is not true. We're trying.
It would be interesting to see it locally, but I don't know
Locally,
that us to do.
Yeah.
We have to find a partner.
Anybody got a boat? You're welcome to that.
Yeah.
Coordinations at one of the yacht clubs. Yacht too.
Definitely not that.
I'm not sure who was first, but science.
I just wanted to know the minimum requirements on vessels, like obviously they need an echo sounder, what other equipment is required to actually participate?
Let me try first. Brian knows more about the hardware and everything. I'm a software guy, but.
I'm trying to shut up, let you.
Yeah.
So we get to the enthusiastic.
So yeah, I mean, you need a echo sounder, a GNSS, you need position and time from the GNSS typically. I think it can record IMU data, doesn't have to. And I think those are the cores though.
That's it.
It needs a CAN bus or so NEMO 2000 or NEMO 183 network. It's essentially just sitting on the network and just sniffing.
And then would there be like the ability to, I guess, filter kind of the data coming in based on the equipment that is on the vessel? Like is that part of the validation process? Being like if you have, say, more higher quality, you might
Well,
get a
Yeah, so in particular for time, it has to figure out time and interpolate that time because when the position comes in and when the depth comes in, they're not gonna come in they're not synchronized, they're not using a single clock. And so it tries to get time from different sources. One of them is GNSS. I'm not sure where else. Is there a time packet? There's a time packet on the network.
Yeah, it'll take time from a variety of different sources, and it tries to find the best one and then synthesize out the time based on that. But the basic, I mean, if you have a chart plotter on the board, that's really all it takes. As long as that thing can broadcast on the network, you can just plug it into the network. Even 2000 is super easy because it provides power as well, so you just connect it. But we put one on the Gulf Surveyor, and all we did was we took the NEMO 2000 cable and went, and that was it. And it came up, started logging and did its thing. That's all it took. NEMO 183 is a lot harder because you have to work out which wires to talk to, and then you have to make sure you get the right way around, which is the problem. Other than that, they said, if you have other things on the network, if you have a motion sensor, like some sailing ships do, for example, it will record that data. It has its own motion sensor on board, like a cell phone style motion sensor. If you have something that was measuring speed through water, for example, which is really valuable, if you have something that's measuring heading, for example, all these things, you can broadcast in the network, it gets recorded in the data stream, and then you can decide what you want to do with it later. The goal, like most professional systems, is you capture as much data as you can, and then you can, if you don't want it, you can throw it away, but if you don't capture it, you're stuffed. Right? So that's the classic. It's intentionally very small, very minimal requirements, so you don't get as much space.
I guess based on all these questions too, have you had a chance to test the usability for non-experts in the field too? So say you have like an engineer who's kind of familiar with how hardware works, see if they can just get it started themselves or.
I think informally, yeah, we haven't done a formal study of it. And there's some challenges still, like if you need to do software update, that's not as easy as it should be. There's options for that. It's just a matter of effort to do it. But it should be fairly reliable, but we've had some people run into some sharp edges, I guess.
The person who's installed the most is a captain of a super yacht, believe it or not, who has no technical background whatsoever and gets scared when I show him a laptop command line interface. But Andrew has installed a half dozen or more of these on his own for the last 6 months on various super yachts in the Mediterranean, particularly, which is his particular ballpark. And we learned an enormous amount when we first sent it out into the world. We found some really good beta test partners, we gave them to them and said, please break these for us. And by God did they break them for us. Sometimes they broke the physical hardware, sometimes that was remarkable. Other times they broke the software, and we've dramatically improved, I think we have dramatically improved the installability and user component of it through that experience, and it will get better the more we do.
I feel like the last ones we've been coming out are just plug and play,
Mostly
user
Turkey.
interface, they don't have to.
Yeah, it has a web server.
We should also mention Adriana does lots of dog work in making these things and send them out for us.
If you've ever set up a router at home, you plug it in and then you load up the website and can do any configuration if you want. This same thing.
But
It would be-
mostly what we're expecting is that the organisation that's doing the data collection acts as a trusted node essentially. We send them blank loggers, or they make their own blank loggers. And the goal is that they do the configuration for the ship before they send the logger out to the ship. So when it gets to the ship, it's basically just connected to the cable and the thing should just come up.
So it would be interesting if you could deploy this, like there are local boating clubs too, where like you could just rent a boat for a day. I think Freedom Boat Clubs is one, and you can partner with them. But then you have like a bunch of random. Habits too.
Actually, that's something that Comet are doing. We're working with Freedom Boat Club, which have, the Comet is based in St. Pete, so what's left of St. Pete.
Yeah.
It's good.
Sorry.
And we talked to Freedom Boat Club with them. They were completely unfazed by the idea that they may have to do configuration, or they may have somebody go and collect the data. They said, yeah, there's no problem. We have people do that. We have people who do maintenance on the boats every time the boat come back in. They want us to collect data from the system. We just add it to their work list. They go down to the boat, they check the oil, they make sure it's fueled up again for the next person, and they pull out their phone, they pull the data off, and walk off. No problem. They were completely unfazed by that.
Yeah, and they're all around the country. I know that. So
What's it called? Freedom?
Yeah,
There's
yeah, I know
one
they.
in Great Bay as well.
Yeah, there's one like right in Colesville, Washington, and they're like all over.
Haley?
So this is super cool to kind of learn about. I guess I'm still wondering a little bit, like, bouncing off a question from Hannah, like, what is like the accessibility of running this on a recreational boat? Or like, I'm trying to figure out, are these boaters who are like super hobbyists, like they have their own echo sounder, talking about the hardware that you need, like they need their own echo sounder, they need their own, you know, something that gets a GPS fix? Or is it as simple as like, okay, you have an AIS running, you might have GPS with that, and you might have like a fish finder with a simple, like single beam echo sounder? Like, so maybe not phrasing this very well, but like, what is that accessibility level, like at the bare bones, you know? You have some excited yachter that's like, yeah, I wanna get into this, I wanna help out.
Yeah, that's a good question.
What, yeah,
I didn't talk about price or cost. Inexpensive is in the name, and I think it is. If you have boat money, you have WIBL money if you can get one, I think. The loggers cost about what, 25 to 75 to produce for us?
The last build we had, they were $35. So manufactured, fully populated with a memory card, configured in the boat, ready to go, was $35. The actual hardware board itself is about 10.
Oh, $35?
Yeah.
Oh, I thought you were gonna say like 3,500.
No,
No,
$35.
that's awesome.
Yeah, yeah, so very accessible if you have boat
The
money.
intent is to make them cheap enough you can just hand them out as freebies.
Yeah.
And if one breaks, the remediation for the breaking is given you.
but then to the second part of that question, cause it's sending data off, but the actual inputs that it needs. And I'm most curious in that actual, what's pinging the seafloor, what does that look like? Yeah,
The logger doesn't care, right? So
Okay.
the logger is listening to one of the data networks on the ship. Whatever you're broadcasting on the ship gets recorded. If you have more than one device on the network, it will record all of them. And then you can decide in post which one you want to do. That actually turns out to be a problem. You'd be surprised at how many ships are completely messed up in their configuration. Because they've added one thing, then they added another thing, then they added another thing, and they forgot to take the first thing out. And then we saw one ship where it had 4 different GPS feeds, 2 of which were rebroadcasts of the other 2, but messed up. So this thing claimed to have 4 different positioning systems, which told you 4 different positions, because it was a sailing ship, and they had a repeater that was bridging between 2 separate networks. They had an older network and a newer network, and they had a repeater that was bridging between. So they had the GPS on this side, which was then getting broadcast this way, the GPS on this side was getting broadcast that way, and they had connected both to the logger, and the logger was reporting everything. And then we had to try and work out which one you listen to, which one you believe to be true. And that's not uncommon. So, like I said earlier, the minimum requirement is you must have something that generates sound in the water and records at depth and broadcasts it somehow, either NEMA 2000 or preferred mode or NEMA 183. If you have something that's doing that, in most recreational boats, it's rare to have a separate echo sounder and GPS. It's typically one unit, chart plot or some kind that does both.
Okay.
And broadcasts on the same network. As long as you have that, that's always required. If you have other things too, we can take advantage of them. If you don't have them, it's not true.
But if you're gonna upload the data, not just store it on the SD card, there needs to be somewhere for it to phone home to. And we provide examples, but we don't host a service to collect the data or store the data.
Right, but we provide the means for others to do it if you want.
Yes, that's where the trusted node comes in. So if an
Remember,
individual
a lot
wants to
of
do
the-
it,
You know, we're saying recreational boaters, but remember, the place where you have the limited data is the place where the infrastructure is poor. So we're thinking about not super yachts in Monaco, we're thinking about subsistence fishermen in South Africa. So they may not have the infrastructure to have their own Starlink system, right, on their small fishing boat there. So the main mode for most of the time for getting data off is you rock up with any mobile device, mobile phone, tablet, whatever. The logger runs its own web server, generates its own Wi-Fi signal for a $4 bit of equipment. And so if you come up and you connect to the right IP address, so you type in, you know, the logger's address, it will automatically feed you all the software you need to talk to them. And then your phone will talk to the logger and can offload the data onto your phone. And then when you get somewhere that has proper internet connection, your phone can then just set up. So you could, you know, walk along the docks get data from that one, get data from that one, get data from that one, get data from that one. Okay, then you go somewhere and you go send all. No data goes up. And because the loggers have embedded in the data format all the information about the ship, its name, its ID number, everything else, you don't have to manage the data, you just send it all in the cloud. Then you can unpack the data and go, oh, that's logger 15 right. So that's logger 23, that's good. And all of that complexity just goes away, it's transparent to the users. Every time we ask the user to do something extra, the number of users we have who are consistently give us data goes down. So if we don't make the data collection piece, completely frictionless or as frictionless as possible, our ability to collect and then maintain a crowd drops off. That's one of the big goals of the project, is to make it as simple as possible to install these things and to run these things, and so you have to just the ultimate goal is we give you a box, you plug it in and you say just leave it alone. So when your boat turns on, the power will come on, that thing will come on, start logging, leave it alone, we'll take care of it for you.
Okay, maybe one more?
Yeah, I already asked the question if you want to ask one.
Yeah, Mr. Okay, you don't want to ask questions?
I do, but we only have time for one, I've already gone, so if you want to.
Go ahead.
Okay, so talking about the simplicity and the user, how are you making sure that you are having all the metadata and not forcing the user to fill the metadata?
Well, on some level, there's metadata that are required or even desired that we don't know. They have to at some point enter it. So they can configure it over the website for the logger. Turn the logger on, log into its website, there's instructions for that. And you can fill in the basic metadata. And once it's in there, it gets shipped along with the data. And then at the other end, that's what the validation is for, is to make sure that when they've supplied the metadata, it's in the right format. And if there's required metadata that's not there, it raises a flag, says, hey, these data, it's not good. It's not good enough. We can't accept this. So that's about as easy as we
The
can
actual
make it.
required metadata is very, very small.
Yeah.
So all you need is it has to have a unique identifier so we can tell that, this data came from that system. It doesn't have to have a name, it doesn't have to have a recognition number, it doesn't have to have any details about the offsets or anything else. It's not like doing a hydrographic survey as we normally think about it. So the actual requirements for minimal metadata are tiny. The more you add, the better it becomes. And so you can add more if you want to. Typically, the expectation is that the individual data collector can add their own metadata if they are comfortable doing so, if they have the technical background to do that. If they don't, whoever's giving them the logger can pre-configure the logger with their metadata. And that's an interaction they have with somebody that's local to them, that they know, that they trust. So they're okay with giving them that information. It's not like, we show up and say, we're the government, we're here to help, right? This is like your local yacht club says to you, hey, we've got these little things, we can make some better charge for the moorings out there, do you want to help? You say yes, okay, well, we get one. Hey, what's the name of your boat? Okay, how long is it? Okay, so what system are you using? Okay. Visual. And it's already embedded in the person that's collecting data just to articulate it. So we focus that metadata problem into an organisation that has some experience doing it or gains the experience in doing it. We don't ask the individual collectors to do it. Again, the more we ask the collectors to do, the fewer collectors we have. So we have to do that as simple as possible. Doesn't mean they can't. If they want to, if they're technically sophisticated, if they want to do it themselves. The whole thing's open source. If they want to run their own system, they can run it entirely. They can pull out the data, look at their own data, pull it apart, put it back together. All tools are there for that. We provide every tool that you use, all the production tools we provide for free. You can do it if you want to, just don't have to.
Well, thank you so much. Those were excellent questions and good discussion, and really appreciate the engagement.
Thank you, everyone.